Hey guys, so today we're going to look at link state and IGRP, BGP protocols. These are different networking protocols and routing protocols. And so let's go ahead and let's get to the desktop. All right, so this is Module 6, Section 3, Link State, BGP, and EIGRP protocols. The Link State protocol, also the shortest path first protocol, is an IGP routing protocol used in packet switching networks. A link state routing protocol has full network topology picture. So it's got complete logical network stored, and it uses 3 different tables per router. And basically what happens is using that topology model and the connectivity of its neighbors. So it pings its neighbors when it gets put on the network, and then it determines the shortest routes. And basically that is the purpose, is it determines where the shortest and the quickest routes are. So if you look at this, is the description table. It kind of describes what it is. Router communication, it basically floods information to each of the routers on the network, and it determines their connection status. It creates a database of routers and link status on the network. It uses bandwidth very efficiently, because once it establishes that, then it's able to send messages the most efficient way possible. However, it does use a lot of the memory and CPU of the routers, because it sends out so much information. It just, in the beginning, when it's being established, it just floods the network with information. And that's the way that it gathers the information for its database. Then you got a participation activity. Open shortest path first. This is another routing protocol, also used to send IP routing information over a single network. OSPF is a transport layer, or layer 4. It uses IP 89 or IP protocol 89. Does not need TCP or UDP, which lowers the headroom, lowers the resource requirements. Instead, it is encapsulated in the IP datagram. Basically, it uses IP packets versus TCP and UDP packets. It's low cost. Basically, it uses a lot less bandwidth than does the previous protocol. The data path is determined by choosing the lowest cost path to the final destination. This may not be the shortest path. It may be a longer path with less hops, or it may be a less busy path. It chooses the lowest cost path, the shortest path. Each link or connection is assigned a bandwidth metric value. A higher bandwidth generates a lower cost value. So if you've got one possible path that's through a lot of fiber and one that's through a lot of copper, well, the higher bandwidth is going to go for a lower cost value, and that means that router using that protocol is going to pick that path first. It uses a link state advertisement message to distribute changes or initial startup information to other routers. So it sends out information about its network in the beginning. Table contains full knowledge of topology. So it establishes also a routing table with a complete topology of the entire network. Each network is enabled, or each network enabled router builds a database described in the network topology and the logistical topology, or logical topology. It routes traffic within the network. The router database is used to calculate the shortest path first algorithm. That's a specific algorithm that we talked about earlier that looks for the shortest path based on bandwidth cost. It authenticates protocol exchanges, provides support for multiple paths of equal cost. And so sometimes it just picks one at random if there are 2 that are pretty well equal. It supports both V4 and V6 of the Internet Protocol. Another activity, make sure you get these activities done because they are part of the grades. Border Gateway Protocol is an exterior gateway and enables the Internet to exchange routing information with autonomous systems. So basically, this is what allows your router to get routing information from the internet and share routing information with the internet. There are thousands of small autonomous systems connected together that make up the internet, and BGP is a protocol for routing the data path through those multiple autonomous systems. It's a layer 7 or application layer protocol, and it uses TCP port 179. So if that port is not enabled, then it's not going to work. BGP assigns the first valid path as the current best path. So it basically goes out and takes that first path first. Then it compares the best path to the next path in the list. And if that path is better, then it replaces it as the best. If not, it keeps the current best path. Continues to the next path in the list until it reaches the end of valid paths. So basically it just tries every one, and then it uses that information to establish the routing information. Main metrics, the weight, a Cisco proprietary value ranging from 0 to 65,535, which is a integer. The highest value is preferred. So basically you're after higher values. Originate prefers the path that the local router originated. AS path prefers the shortest AS path, and origin code prefers the lowest origin. IGP is lower than EGP. EGP is lower than incomplete. Incomplete is the highest. So once again, you have another participation activity, and then a hybrid. EIGRP basically uses a lot of these different protocols to establish the most efficient pathway for sharing information. It's a distance vector routing. I'm having trouble speaking this morning. A routing protocol used to send routing information within an EIGRP. It uses uses IP protocol number 88. It was developed to address limitations in IGRP, but also to link state protocol characteristics with characteristics of a distance vector and a link state. It's a protocol, so it uses characteristics from both different kinds of protocols. Major difference between IGRP and EIGRP is that EIGRP uses a topology table. The topology table stores information advertised by network neighboring routers about their known routes by maintaining details about feasible path, reliability, reported distance, and the total delay. So basically, it establishes a routing table based on the logical topology of the network. It has a maximum hop count of 224. These are the characteristics and the strengths and weaknesses. It's faster than IGRP. It exchanges router information more efficiently. It is more scalable. That means it can add and take away routers pretty easily. Your network can grow a lot faster using this protocol. It's backwards compatible with IGRP, which means that basically if you have an older network set up on the older protocol, this will work. It uses hello packets to notify neighboring routers that the router is operative. If no hello packet is sent after a certain time, then the router is considered offline. And the neighboring router has to send a hello packet in order to put itself back online. EGRP updates neighboring routers with changes, only not an entire routing table. It does not send the entire routing table every time, which cuts down on the amount of bandwidth that it uses. And so it's a more efficient and a lighter weight protocol. And then finally, it improves voice and video quality. If you're doing voice over IP telephony, or if you're streaming video, this is a more efficient way to send those packets. Another participation activity, and then a challenge activity. And that should be everything that we need. All right, guys. So basically, if you have any questions about the different routing protocols and how they're used, go ahead and send me a message on Canvas inbox or ask me in class. The information for routing protocols that you're going to see on the test is not that detailed, but it is going to ask you some specific questions. So you want to make sure that you've got the information down. You at least have a general idea of what each of these routing protocols does and the difference. Say, for example, the difference between EIGRP and IGRP. But if you know those things, you shouldn't have any difficulty with the test. Once again, if you have any questions, please let me know.